What if the sound of your own voice was completely alien to you, dictated by the raw physics of another world? Have you ever tried to imagine how your very essence, the way you communicate, would shift under an alien sky? We're about to take a hypothetical voyage to every planet in our solar system. From the smallest silent rocks to the roaring gas giants, we'll discover how each environment would warp and twist the sound of your voice. And yes, we'll find out if anyone could hear you call for help. Our journey begins with the smallest planet, a world of terrifying duality. Mercury. Named for a swift messenger, this world is ironically a place of profound silence. It dances dangerously close to our sun, yet it's not the hottest planet. Why? Its days are an inferno, reaching a blistering 427 degrees Celsius. But its nights, they plunge to a bone-crushing minus 179 degrees. These nights aren't short. They last for 3 Earth months. This extreme swing exists for one brutal reason. Mercury has almost no atmosphere to speak of, just a ghostly exosphere of scattered atoms. Sodium, oxygen, helium, but nothing you could ever breathe. So, if you were a native of this scorched and frozen rock, you'd likely evolve a dense, metallic-hued body for temperature control. But you still couldn't breathe its air. And without breath, you could never make a sound. To scream on Mercury, you'd need to evolve beyond the need for oxygen itself. But even then, your scream would be utterly, completely silent. No one would hear it. Sound is a vibration that needs a medium to travel. Air, water, solid ground. Mercury's wispy exosphere is practically a vacuum. The vibrations from your vocal cords would have nothing to push against. They would simply die at the source. On Mercury, your voice isn't just quiet, it's a physical impossibility. But there is one way to hear this silent world. Press your ear to the ground during a Mercury quake. You'd feel the deep, subterranean groans of the planet itself through the rock. A profound, terrifying rumble. But don't get too comfortable. The ground shaking on a world of such extremes is its own kind of nightmare. Mercury is a study in silent extremes. So let's travel to its opposite, a world where the very air is a crushing, roaring ocean. Venus. Of all the rocky planets, Venus possesses the most dense and oppressive atmosphere. Here, sound doesn't just exist, it dominates. To understand why, we need to journey not to the clouds, but inside your own ear. Your hearing is a marvel of earthbound evolution. Your outer ear captures waves, tiny bones in your middle ear, the smallest in your body. Amplify them. Deeper still, the spiral-shaped cochlea turns these vibrations into electrical signals for your brain. It's a system fine-tuned for the specific pressure and composition of Earth's air. Hearing is the bridge between your mind and the universe around you. And that bridge is built on a foundation of subtle vibrations in a familiar medium. But what happens when that medium changes catastrophically? Venus's air is a supercritical soup of carbon dioxide, so dense it acts like a fluid. It traps solar heat, making the surface hotter than a pizza oven, over 460 degrees Celsius. The pressure down there is crushing, equivalent to being a kilometer under an Earth ocean. To survive here, a Venusian you would be stout, with mirrored, heat-reflecting skin and bones reinforced like steel. But your voice would be monstrous. In that thick, soupy atmosphere, your vocal cords would struggle. The sound waves would be massively distorted. Your pitch would drop into a subterranean range. You would sound like a giant speaking through a wall of molasses, a deep, booming, and slow growl, a tiny being with the voice of a titan. And it gets stranger. Sound actually travels faster in Venus's dense air, about 410 meters per second compared to Earth's 340. This speed shift would warp the frequencies of your voice in uncanny ways, creating a bizarre, otherworldly resonance. You didn't evolve for this. Your Earth-born ears and voice box would be utterly lost. But what if you lost your connection to sound right here on Earth? For millions, that bridge is crumbling. Hearing loss isolates and is linked to deeper risks like depression and cognitive decline. But what if you could rebuild that bridge from the inside out? One company is pioneering a path by looking at the very anatomy we just discussed. Instead of external aids, they develop fully implanted systems that use your body's own natural mechanics. A tiny sensor picks up vibrations directly from the bones of your middle ear, sending signals to your inner ear. No external mics, no daily maintenance. An invisible solution working 24/7. It's a fascinating leap in auditory technology, making authentic hearing a seamless part of life again. To see how this inner ear revolution works, the link is in the description below. Now, back to our cosmic voice experiment. From the crushing pressure of Venus, we voyage outward to a world defined by its thin, toxic air. Mars, the red planet. Its atmosphere is only 1% as thick as Earth's. It's mostly carbon dioxide and bitterly cold. If you were born here, you might be taller and thinner to manage resources with large eyes and dark, radiation-shielding skin. For your voice, it would be faint, weak, like whispering in a vast, empty warehouse. The thin air wouldn't carry sound well. The shout might only travel a few dozen meters before fading into nothing. Conversations would need to happen up close, and the sound itself would be higher pitched, tinny, and brittle. Mars is a world of quiet desperation, where even a scream feels lonely. But for true cosmic vocal distortion, we must leave the rock behind and dive into the realms of the giants. Jupiter, a planet with no solid surface, only endless, deepening layers of gas. The pressures and temperatures here are unimaginable. If a human-like being could exist in its upper cloud decks, what then? Your voice would be deep, warped by hydrogen-helium soup. But the real story is the noise around you. Jupiter is a cacophony of howling storms, electromagnetic whispers, and the creaking of its own immense magnetic field. Your voice would be a tiny, insignificant drop in a perpetual hurricane of sound. You wouldn't hear yourself think. And then Saturn, similar to Jupiter, but with even lower density. Your voice might become slightly higher, almost squeaky in the lighter mix of gases. But again, you'd be drowned out. This time by the eerie radio frequency screams of its auroras and the phantom sounds generated by its rings. But for the ultimate vocal paradox, we travel to the ice giants, Uranus and Neptune. These worlds have ices in their atmospheres, water, ammonia, methane. Under the incredible pressure, these form supercritical slushy oceans. If you could speak from within such an ocean, your voice would be nothing. Liquid water is a poor transmitter for human vocal sound. Your words would be muffled, garbled bubbles. Communication would likely shift to low-frequency rumbles like whales in a deep, dark alien sea. Our final stop is Pluto in the freezing Kuiper belt. Here, with almost no atmosphere, we return to silence. Any atmosphere that briefly thawed would be so thin, so cold, that sound waves would freeze in their tracks. Your voice would be stolen by the cold, a secret kept forever by the ice. So, from the silent stones to the roaring giants, your voice is not your own. It is a gift. Or a curse of your atmosphere. It makes you wonder, doesn't it? The fact we can hear each other clearly share ideas and stories is a fragile miracle of our specific, beautiful, blue world condition. If you enjoyed this journey through the physics of sound across our solar system, please show the algorithm you want more by liking this video. It truly helps our channel, Winds of Thought, explore more ideas. And tell us in the comments, which planetary voice disturbs you the most? The booming bass of Venus, or the lonely whisper of Mars? Subscribe to Winds of Thought and hit the bell for more journeys to the edges of understanding. Thanks for listening.
What if your voice wasn't your own, but a strange echo of the world you stood upon? On Venus, that echo would be a deep, resonant boom. The dense, soupy air would weigh down your vocal vibrations, twisting your normal tone into something distorted and powerful. You wouldn't sound like yourself. You'd sound like a giant trapped in a vat of oil, your words emerging as a slow, rumbling growl. This creates a fascinating puzzle for your ears. On our world, human ears are fine-tuned for higher frequencies. Birdsong, rustling leaves, the voices of children. On Venus, your auditory system would need to adapt to catch the deep, bass-heavy thunder of the environment. Your outer ear might shrink to reduce pressure stress, but your eardrum would thicken into a less flexible drum to withstand the constant crushing weight of the atmosphere. You might even develop fluid-filled inner chambers, much like a crocodile, to better sense those low-frequency rumbles. The catch? You still couldn't breathe. That carbon dioxide-rich air means you need a radically different biology to survive without a suit. Let's leave this pressure cooker and journey to a world where the air is almost absent. Mars, won't be tall? Mars is your place. With just 38% of Earth's gravity, you could evolve a lean, elongated frame. Walking would feel effortless. But speaking, that's another story. The Martian atmosphere is tragically thin. A scream here wouldn't carry. It would die a few meters away, emerging as a muffled, pitiful whisper. You'd need superpowered lungs just to pull trace oxygen from the air. And your voice would undergo a bizarre shift. Sound travels slower in the cold, thin Martian air, which would lower your pitch. At the same time, the CO2-rich atmosphere would absorb higher frequencies. The result? A voice that's quiet, deep, and muffled, like you're speaking through a thick wall with a helmet on. Trying to hear someone with a high-pitched voice would be nearly impossible without help. For a truly dramatic vocal change, we must leave the rocky worlds behind and enter the domain of the giants. Jupiter. Here, there is no surface, only endless, deepening layers of gas. In the upper cloud decks, pressure is Earth-like, but the air is a light mix of hydrogen and helium, and it's brutally cold. Your body would adapt with less dense bones, more muscle, and dark protective skin. But your voice, it would betray you. After Venus, you might expect another deep bass. You'd be wrong. In Jupiter's light atmosphere, sound travels 3 times faster. Your vocal cords would vibrate with little resistance, shooting your pitch into the stratosphere. You'd sound like a frantic, squeaky cartoon character. Of course, breathing is impossible without evolving to process hydrogen, and your tiny squeak would be lost in Jupiter's eternal, roaring symphony of storms and lightning. You'd have to scream just to hear yourself. Its cousin, Saturn, presents a similar story. Another hydrogen-helium atmosphere, even colder. Your voice remains high-pitched and fast, competing with winds that scream at over 1,000 miles per hour. The planet itself generates a ghostly, methane-tinged whoosh with deep thunder. On a rare calm day, you might hold a comical, squeaky conversation, if you were close enough. Breathing? Again, impossible without miraculous biological tech. Now we push further into the freezing dark. Uranus, an ice giant. Its upper clouds are a frigid minus 200 degrees Celsius, a mix of hydrogen, helium, and a significant amount of heavier methane. If you could vocalize here, your pitch would still be high, but not as extreme as on Jupiter. The colder, slightly denser air with that heavy methane slows sound down a little. Your chipmunk screams would still carry far, but Uranus is a quieter, more bland world weather-wise. Your voice is a prisoner of the air that surrounds you. It does, however, smell absolutely horrific, reeking of rotten eggs from hydrogen sulfide. So, if you could breathe, you'd wish you couldn't smell. Finally, we reach Neptune, the solar system's windiest psychopath. Neptune shares Uranus's atmospheric makeup, but the weather is pure chaos. Winds tear across the planet at over 1,500 miles per hour, a constant deafening roar that would whip away anything not anchored. Your voice here would be the same high-pitched squeak, but it wouldn't matter. No one would ever hear you. You would be a tiny, screaming speck, utterly lost in the planet's relentless, turbulent howl. So, here's the cosmic vocal scorecard. The gas and ice giants turn you into a squeaky toy. Venus morphs you into a booming subwoofer. And Mars merely begs you to stop mumbling. Mercury, as we know, prefers utter silence. In the cosmos, your voice is not an identity, but a physics experiment. Surviving these worlds is a challenge for another day, but it makes you appreciate the delicate, invisible cocktail of our own atmosphere that lets us speak and be heard, connect and understand. If this journey through alien acoustics resonated with you, please give this video a like. It fuels our mission here at Winds of Thought to explore the universe's deepest questions. Tell us below, which planetary voice is the most horrifying? Subscribe to Winds of Thought and turn on notifications for more explorations of reality's edges.